Can you hear me well?
Yes, I can. Can you hear me okay?
Yeah, perfectly. So I'll start with a quick introduction. Although it's anonymous, I'll share my background. So I worked at Amazon for 7 years as a software engineer and then a software engineering manager, and I moved to a startup at the beginning of this year to build automation for filing requirements at companies, so the government. And so with that, I'll pass it over to you to give me a quick introduction about your background.
Okay, so I'm actually worked as a data engineer for about 3 years now. The reason I'm doing this is trying to brush up my software engineering skills because I am encountering interviews where they do sort of ask some SE questions. I don't feel like I'm technically as strong as, say, a pure SE is, but I've been trying at least to practice. So, yeah, currently interviewing for my next role.
Great, sounds good. So with that, I think we can kick off the coding question, if that works for you.
Okay, yep.
So what language would you like to use for the to code it?
I like to use Python, actually.
Okay, sounds good. Let's switch the IDE to Python. And is it your first interview on interviewing.io?
Yeah, it is.
Okay, great. Well, you'll notice that this is there's actually an interpreter. So if you run the code, you will be able to see the output on the right side. You should be able to see my cursor, and I can see yours as well. So it will make collaborating easier. So we'll start with a very like a warm-up question. So I'd like you to write a function that, given a string, will return the number of words in the string. And I pasted the description right here.
Okay, cool. So I can just get started?
Yeah, go for it.
All right, cool. So I guess just in my thought, so if we have a string of words, like just say in this string of words, there's going to be, we can probably go by the spaces. There's always going to be S-1 spaces, right?
Yeah, that's a reasonable assumption.
Number of words minus 1 spaces. That's words. Then I guess we have to watch out for edge cases, maybe empty string. And yeah, if this is for a warm-up, hopefully it won't be too complex in terms of the code. So I'm gonna probably go ahead and start from here.
That's a reasonable assumption.
And let's say, pretty sure there's a built-in function, right? So num spaces if not string return 0, then num spaces would be string.count. I guess one thing that could happen is, if there's multiple consecutive spaces or white space till the end, should I account for that, or are we assuming it's pretty clean?
Let's assume it's pretty clean, but yeah, good call out.
Okay, cool. So let's run through this real quick. I guess this is fairly straightforward, so it looks good. On here, let's say we took something like string of words, the if not string, it's not empty, so we don't return 0. No spaces because string dot count spaces. It'll count 2 spaces, so it's +1. It's not -1. Oops. So 2 spaces, 3 words. Yeah, I think that makes sense.
Looks pretty good. Should we run it on an example?
Yeah, sure. Can I just use print or?
Yep. You can see you have sample code at the top that shows you how, to run stuff in the IDE.
Oh, okay. So I guess. Autocomplete. Look at this whirl. Oh.
Neat. Well, that looks pretty good. I'll ask you a question about this algorithm. Can you determine what the time complexity for it is?
I believe it should still be on, because if it's counting through a string, it's an iterating through it one by one, so it has to iterate through the whole thing for a string. So on.
Yeah, makes perfect sense. So thanks a lot for going through this. We'll move to my next question. Does that work for you?
Oh, yeah.
So this is a word combination problem, and I'll paste the description right here. I'll give you a minute to read through it and let me know if you have any questions.
All right. One moment. Your game prediction, large last words. Rockstar. Or more words from the same list and print. Super plus high plus away. Rockstar. All right, interesting. So in your example, rockstar could be rockstar, rock with an S, rocks, and tar.
Mm-hmm.
And I see a duplicate star. So should I be counting 2 rock and stars?
That's a great question. Let's say yes. I think that's reasonable.
Okay. All right. Let me brainstorm real quick. So, naively, maybe it's a naive solution. Would be we iterate through it. So we hit rock star, and then we have to check every time through the list. That would give us an n squared method to it. Is there a better way? So let's see. Let's start with, I guess, going for a naive solution. If there is a better,
great.
And then we'll see if I get any insights on if there's a different way to implement it. So iterate through lists of words, and I see a potentially large, so I'm guessing there might be a better way doing this. For each word, iterate through the list again and identify if it's actual composite for the word. If the word is longer, then we can skip already. And let's see if there's rockstar. If I go all the way back, how would I compare if the word is part of it? That might even add some more time complexity to it. Rock star. Then I have to keep track of the part. And I guess a question, two or more words. Oh, that makes it even more tricky with the super high way. So I guess, how would I even map 2 words to a single word? Because, all right, there definitely should be a different way to do this, because I'm thinking, say a word is, let's say a word is like superhighway, which is made out of 3 words. How do I know to stop checking through the list over and over without, maybe I guess you could specify the length if the
I think that's a reasonable question. How about we start with maybe 2 words, right? And then we can think about how we might solve for any length, right, for the combination. Does that sound good?
That sounds good. All right, so I think we have a good idea of what's going on here. So let's call this this. So first thing we want to do is iterate through the list of words, and then we're probably going to need a counter. Keep a list of sort of possible combinations. If returning the output would be a list of lists. Okay. So our final list equals this. Potential composite equals a string. And so if we're iterating this for W and R list for listener list. So we'll do our first check for the length. If the length of W is greater than less than equal length of S, then we're saying here we're doing a comparison, right? If this is there a starts with function for strings? I'm going to assume yes for now. If not, then I'll go back and code for it.
Yeah, that sounds right. You know what? I'll do a quick look online, see if that's the right function. I'll let you know.
Oh, cool. Thanks. I appreciate it. So it looks like I'll have to keep track of two things so I don't have to keep unpacking and repacking. Potential string plus equals S and potential composite append S. Then all right, so let's say it's rock and star, and we covered rock, and then we want to go along with this. So I think one way would be for our word, we want to adjust it. Instead. And then do we have to keep track of potential string? So if we have a current string and it becomes shorter, so say rock star, and we found rock, then if we drop the rock part and then try to match the next part, then that's a potential way as well. Let's see, what would be the time without adding too much complexity. So one way is if so we set current to word here. If the length of current is length S, we can just skip it. If current dot starts with S, so take that out for now. So if I have rock star, I found rock, and then I want to trim off the rock part. I guess one way is to slice the word. So per equals per length of S. Okay, and this might, let's see, hopefully we'll handle two. And then we would, we need to be able to append to our final list, right?
Mm-hmm.
All right, so hopefully if we, this is not right, this is, so 1, 2, 3. If length cur equals length, so I can't do this right away, this check, because it might match. So I'm thinking now if you have Rockstar, obviously I want to distinguish between matching one whole word with a word, but if we're trimming down and we have star left over since we found rock and star matches star, then
I'm tracking. Yeah, that makes sense.
Okay, but the way we're doing it, I guess, won't account for this duplicate for now. We can maybe go back and see what we can do about that. So if Lanker so this would just be if the length of word. So I think that would handle if it being the same string for checking, and then if cur starts with S, essential composite dot append S cur equals. So here we should do a check. If cur dot append potential composite. equals else cur equals cur lane s is 4. Potential composite rock stars rock star. Then so I'm thinking if we have a duplicate, then we can keep this and count it again, or we can crack it separately. I'm guessing the best way, I'm just thinking the best way to handle duplicates is sort of maybe keep a separate count and double check if we touch that. It will add space complexity, but it will help if, say, we have a multiple words and multiple sub strings of it. Let's revisit.
Yeah, we can revisit that later. Just like the multiple word breakdown.
Okay.
Although it looks like your algorithm would work with multiple words, right? Super high way would actually be broken down into 3 words, right?
Let me see if super high. It would if the only catch is, well, I was thinking for multiple, I say for super highway, right? If way and high were positions were switched, it wouldn't be able to catch that, which is probably I didn't like my method as much in the beginning. But given this order and ignoring that duplicate star, let's walk through. Actually, I haven't even appended to else cur equals cur. Exited out of this loop. So if cur equals constant, cur equals pen potential composite. So turn potential. I'm using this anymore. Let's get it out for now. Turn composites. So I'll walk through my code real quick. Let's take this. Let's get better down here. And for now, I'm going to remove this. All right, so forward in our list, so I start with Rockstar. I set the current to Rockstar. We're string in our list. If the length is the same, they're going to be the same. Rockstar matches Rockstar. Continue, because that's not actually valid. If then we move to rock, and it starts with rock, so we're going to append rock to our potential composite list, and cur that starts with, and then if cur equals s, so no, not for this. Else current equals current lane s to 4, so lane 4, so 0, 1, 2, 3, so 4 onwards. Leave us with star as our current. We move on to star if lane 4 less than or equal lane s. So rock star is larger than star, so this condition would hold. If current that starts with star potential composite dot append s, so we have rock and star. So, okay, I already can see something already happening down here, but let's finish walking through this. If current equals S, so star matches star, then we found one. We don't want to break because rockstar is rockstar and rockstar. So let's see how we can fix our logic for that. So first of all, we don't want to exit the loop early. We'll just let's set it again. So all right, so we reset it to rockstar, and on this one it's going to check it's going to be okay. All right, so one glaring thing is my method only definitely works if the substrings happen after the word. So is that true? Actually,
yeah,
no.
that's a good catch.
Actually,
here's a
no.
suggestion. How about we track the things you've identified that need to be improved for the function to cover all the different edge cases, and like maybe below this as comments. And once we do that, let's try and see if we can run it on an example. Does that work for you? And then we can go to adding support for the edge cases you've identified.
Okay, sounds good. So give me one quick moment. So if we hit rockstars, I would start again at rockstar and would not find an S. So that fit. So for rockstar, rockstar, tar. Superhighway high, rockstar, and for S in the list. So rockstar. And then I made it into an S. And it won't match. Okay, yeah, so I mean, we can try running it on something that's in order, but I think, is that okay with you for now, or should I just go ahead and try to make it at least work out of order?
Let's try as it is right now, and just note that working with the order is one of those things we can improve. Does that sound good?
Sounds good.
Right, so, I think you've identified order, you've identified finding multiple examples of like duplicates. You talked about multiple keywords, but I think that's supported. Yeah.
Okay.
Yeah, that's pretty good. And also I checked starts with is a function, and it's actually with all lowercase. This is how it's spelled. I believe that will work.
Interesting. Cool. I guess Python doesn't like camel cases in its base code. All right.
Yeah, that's right. Snake case, right? That's why it's called Python.
So I'm going to go ahead and rearrange this list real quick. For first implementation. I wrote multiple concatenations because I have a feeling when we hit superhighway, I'll be able to catch superhighway, but I'll forget about super, so I won't be able to catch this multiple actually. So we can actually test two versions of this. So
Sounds good.
then what I want to like to try is delete highway from here. Other function composite list. Let's give this a whirl. Did not error out. That's one good thing. Got some spaces here. Some visual clarity. So, first of all, it's not giving our list of lists that we like, but Rockstar. So, I'm not resetting potential composite, so that's probably because of that. So that's one thing. Rockstar.
Yeah.
Super. So we do have duplicates. Do they look the same? Yeah, I'm just appending the same thing over and over with a final. So look at this one. Rockstar. Rock. Excuse those super high. Is there? I can't scroll to the right.
What are you trying to look at?
No, it's wrapping. That's why I thought there was more things to the right of the output.
Okay, yeah, makes sense.
Super highway and highway, super highway. So yeah, this output's kind of jumbled for me right now. So let's clean that up real quick to at least get it a bit better looking. So composite set up pen potential composite. Where should I reset this potential composite? So it should be here. Why do I get this weird long one still in high way by missing the super? So debugging this real quick. Rockstar Rock Super Highway. Where does this happen? So Rockstar doesn't handle both as we see. So it goes to Rockstar. Rockstar gets Rockstar and Rock, but somehow it gets Super and Highway.
That's a bit odd. Oh, try another preset thing. So append for the string. It's a good question. So are you familiar with the difference between append and extend?
I am, yeah.
like should one be used like in either of those places instead of the other? I don't think so, right? Because it depends, like you're adding an element to a list. Yeah,
Yeah,
that looks right.
true. But I mean, us is a string, so this is definitely an append. This is a string of strings, so this is also should be an append, right? Give me one moment. I'm probably spending too much time on this one problem, but here goes. Rockstar. I'm guessing it does error out on rock stars. It's sometimes identified as rock. Let's see if see how through our logic. Continue if cur that starts with W, so potential composite, we'll put rockstar in it, and then if cur equals S, and it doesn't, cur equals W, so else cur equals cur of lame S to the end. So this should technically make it an S, and it should not match ever again. Length word is less than length S, continue rock. So I'll keep in mind what you said as well. For S and Rockstar. Let's see. Cur that starts with S. Potential composite append S. We put in Rockstar. If cur nope composites, else cur equals cur lane S to the end S. S. And then this never happens again. Ideally through the string. Am I not clearing something that I should be? Sorry, I'm generally confused why.
A little bit, yeah. Same here, actually. I'm stumped. Maybe printing what the W and S are in your loops will help us follow the algorithm as it's going through. Does that make sense?
Okay. Yeah, if you don't mind. I know sometimes people don't.
Go for it.
All right, cool. So this might be. Let's try that out. Guess if we really wanted to. Let's just run one. And let's see if we can find this. What happens here?
I think I have the start of intuition for what's going on. Maybe like the rock stars board, right?
Pardon?
I'm just saying, so I think I have an intuition for what might be going on, where
Sorry, I'm gonna take a stab before you
go for it.
reveal it to
Yeah,
me.
makes sense.
I'm guessing that because of this condition here, and this, or perhaps this one here where they don't match, along the way, potential composite doesn't get cleared because it didn't find a match. So this never triggers. So potential composite stays populated. So we get this weird behavior of no match, but potential composite still filled out. Was that what you were gonna say?
That's right. That's where I was going. I think you're correct that there's a reset that doesn't happen for some reason.
Okay, cool. So let's reset. Start with if it finishes as a loop, I guess. Does that make sense? Let's see. If it runs through it and it runs through everywhere possible, there's no match, then yeah, I think it should reset here. That's one thing we didn't reset properly. Cur and potential composite, and we don't want to reset our composites because that's just our master list. Cur does get reset here as well.
Yeah, I think you got, like, at least what you've just fixed is what I was thinking of. That reset for the potential composite list.
Okay, cool. Shall we give it a whirl?
Yeah, let's do it. Maybe without all the screens. So
it's not as cluttered. Yeah, I guess. Whoa, whoops. I have another print statement or two.
Well, that looks pretty good.
Almost. It's the second super that I was hoping would be accounted for.
Yeah.
How
but I mean, you've got the breakdowns into two words, at least all of them.
Oh yeah, that's true because we have a highway here. So yeah, cool. How are we on time? I'm happy to try to continue to implement.
Yeah, I mean, this is a pretty good break point. Usually, like, it's around 45 minutes. Towards the end, I like to turn it around and have the candidates ask questions to me, the interviewer. Right, so we could role play it a little bit. I'm curious to know what questions you might ask.
Okay. I'm just going to ask a quick, just an outside meta question. Is basically, I think you mentioned you had a lot of experience as an engineer. For me, obviously, my reason for using interview.io is because it's good practice. I guess what's the motivation? Because I'm guessing you guys have plenty of experience. I would at least think at first in interviewing people, but what's basically your motivations for using interview.io?
Good question. So on the interviewer side, it's good practice in general, and it, like, there's an aspect of it which is about giving back, like making sure that everyone in the community gets an opportunity to practice interviews so that they eventually get, like, the roles that they're looking for. So that's why I do this with interviewing.io. I've also recently, when making my switch to a startup, I went back to interviewing.io to take interviews myself. And this is because the day-to-day work is different from the interview. The interview is really an exercise that you prepare. It's like an imperfect way to quickly evaluate people's skills and familiarity with data structures, algorithms, coding in general. But since it's a bit contrived, right? Like when you work day to day, you rarely write algorithms from scratch. You usually, can Google for things, look at Stack Overflow. You also work with your IDE. You write tests and check whether your tests pass or not, and that's how we code. And so interview questions are a little bit different, and coming to terms with that and accepting that you have to practice to get back in shape for an actual interview is, I think, true for engineers. Even people who spend their days, working as engineers probably will need to do some interview practice before going through an interview.
I see. Yeah, that's a great answer, actually. So maybe going back into what I would probably ask during my interviews, I guess most of my questions are relevant to just day-to-day at X company. So for you, like what, say hypothetically, like what I've been working on, what are some maybe pain points, what's going on, or some needs that the company is trying to fill?
Yeah, that makes sense. What I can share is like some other questions I've heard and things that I think usually make sense. So an interview goes both ways. Oftentimes you also interview the team that you're going to join. So having an understanding of their, day-to-day practice, if they use a version of, Scrum or Kanban, an understanding of the challenges that, as you said, like that someone's working on. And one way I've heard it framed, that question, that actually works really well is, what's a project that you're looking forward to in the near future? And even more specifically, I've heard someone ask, what's a tech debt project that you're looking forward to? And this is a good way to get an understanding for, one, is there interesting work going on? And two, is the team on top of the quality of the software, right? Like understanding whether there's a lot of operational load, meaning working on fixing bugs, right, or urgent issues versus new greenfield work.
I see.
So that's a good angle.
I see. That's very interesting. I never thought about it that way. I guess for your experience, how much do you value someone who's demonstrates a willingness to learn versus the actual skills? Like, how would you weigh it on an interview? Like 80% being able to get the right approach, the right solution, 90%.
Good question. I'd say what matters most is the ability to write code, right? So this is like a binary test, pass or fail. Like if you can write code, we then look at communication, problem solving, dealing with ambiguity, and I think the depth and fluency will determine the level, right? Like for the role you might enter, might be an entry position, or it might be like a more senior position. But that's what comes into an interview. And testing for the willingness to learn, the ability to, take feedback and act on it, that's actually key, because at any level of experience as an engineer, like you just keep learning every few years, few months. The landscape changes so much that I think part of the skill set is being ready to, unlearn things and learn new things and adapt to trends. So.
I see. Yeah, that's really a pretty great answer. And I mean, to the common, like we always keep learning, but I guess now that you mentioned it, they probably, do separate, that aspect to behavioral interviews, and the technical one is a bit more binary. I would assume like
yes and no. In my experience, the coding questions are like have a binary component. Again, it's can you write the code or not, right? And once you pass that bar, really it's all about probing for those softer skills around development, knowledge of data structures and algorithms for sure, but really also how do you react to maybe a bug you see in the function? How do you think about all the edge cases? Can you break down a big problem into smaller chunks where you iterate towards a solution? A lot of those things are what interviewers look for when doing the technical interview.
I see. Okay. those are some good points. I think I do definitely need to work on how to break down these problems into smaller ones.
One thing I'll share is like you did pretty well, I think. Like I tend to ask similar questions over and over again. Like you're one of the few people who arrived at a working solution in this coding question. It's not a straightforward one, so like that's another leveling thing to be aware of. The warm-up question was really the binary, can you code or not, and the second one was really, it has drawers, so you can go deeper and deeper in terms of depth and complexity. So getting to a solution's already, passing a bar.
I see. Okay, cool. Because I mean, as an interviewee, I'm always like, one, we know we don't lose anything by keeping on trying, but it's always like that dreaded moment where you don't actually know all the answers. But yeah, being able to hear, I guess, feedback and be able to break it down in my head a bit more definitely does help. I think that's all the questions I had for now.
Makes sense. Sounds good. I mean, this could be a good break point for the interview. So one last thing I might ask you, this is something that probably would have come up, is what's the time complexity for the algorithm you wrote?
Okay, so let's take a look. So we already have 2 for loops through our one list, so that's already going to be n squared. And this is going to be additive, also additive. So it's n squared.
Yeah, that's right. And you asked if there were like ways to make it, more efficient, and so there definitely are. So this is like, it's a fun, interesting question that again has a lot of depth and can go into optimization. Recursion can also be helpful in some cases. So
I see. So is this actually a dynamic programming problem?
I am actually not familiar with dynamic programming as a category of problems.
I see. I guess basically recursion, right? Since let's see. Interesting. Yeah.
Because essentially, when you find a breakdown, like the next step is trying to find a breakdown for the subset of the word that you've identified. So that's one way to think about it. But like another thing that can help is sorting by length. So you only look at stuff that's relevant. That's another way to shorten the actual search.
I see.
But you had the right intuition from the get-go, thinking about the length of the word. So
yeah, actually, I probably missed that. I was just trying to think of what you just said. If we did sort and then sort of maybe implement some sort of recursion at a high level, I'll have to think about this. I obviously wasn't able to put that on the fly, but cool. I will keep that in mind.
Makes sense. Cool. Well, it was a pleasure doing this interview with you, and so best of luck with the next one.
Yeah, thanks a lot. This was definitely, at least for me, very valuable practice, and I appreciate the feedback as well.
Great. Good to hear. Have a good rest of the day.
Cool. Awesome. You as well. Take care.
Bye.
Bye.